All right, in this video, we are going to start implementing the first remove method in the linked list. All right, so that is return type E, remove, and it has one parameter of the int, which is the index that you want to remove at. It says remove the element at the specified index and throw an index out of bounds exception if the if the index is out of range. Okay. So the header, right, is going to be public e remove int index. And I did the same mistake I did last time. Okay, so just like with the add at a given index, we're going to handle this in two different ways. One, if we're removing at index 0, and then the other case is where we're not removing at index 0. So let's go with index 0 first. Okay. All right. So this has return type E, so we want to return the old element. So really, this should say return and remove the element at the specified index. I need to update that. So we need to save that before we get rid of the node, right? And again, the reason why I'm doing this is just to be more consistent with how Java defines their remove functions in its list interface. So I'm going to call this an old element, and I'm going to use get index. So that's going to call the get method that we implemented a few videos ago. That's going to call get node, and get node is going to throw an index out of bounds exception, right, if the index is out of bounds. So we don't have to worry about throwing the index out of bounds exception there. That will be covered. All right, this saves old elements, and so we can return that at the very end. Okay. All right, so next up, just like in the add at a given index, we need to have an if statement here, and we need to treat those two cases separately. So for right now, we're just going to do the if the index is 0. All right, so if the index is 0, then what I need to do is just change the pointer for the head. So let's see if I can pull up the list here. Okay, so right now in this list, words, head is pointing to M. So all we've really got to do to adjust this is to make it point to the next node along. All right, so we're going to change the value for head, and we're going to change it to whatever it's currently pointing to, right, which is head dot next, and point at the next one. So whatever head's currently pointing at, go to its next one, and then now make head point to that one. So this arrow will go from pointing at M to pointing this one right here, pointing at A. Then this node right here is going to get garbage collected because nothing will be pointed at it. And so this list is going to kind of shrink back. After we do that, right, we'll need to decrease the size by 1 because now we'll have one less node, and then return old elements there. Okay. All right, so that should get us the case where we're removing at index 0. I need to do double equals here. Okay, and so I'm going to add an extra line to test here, and that's going to be, and I guess we'll print it out, system.out.println words.remove 0. Okay. All right, so when we run this in Canvas to check it out, what should happen is this node should get removed, right? And then A should become the first thing in the list. Size should decrease by 12. And then it should print the old value, so M down here. So let's just verify that all that happens. So we can see that node has been removed. The size has dropped from 12 to 11, and it printed M right here. Okay. All right, let's do that again. And step through it this time. All right, so we get the old value out. And then we just create the link from here. We take it and make it point to this one. Like so. And then it's going to return the old element, and that gets printed out. Okay, so that's the situation for removing at index 0. So now if it's not index 0, right, then what do we need to do? Okay, all right, so if it's not there, then some of the things that we need to do, right, is to save the old element, which we've basically already done. And I made the same mistake by writing too close to my diagram. That's okay. I'll just have to redraw it. Number 2, right, is we'll need to get the node before the one we want to remove. So in this case, if we're removing 2, that's going to be the element at index 1, right? So that's going to be head. This points to A. That points to B. C. And then I don't really need to draw the rest of the list in there. So node, right, we'll have a variable called node, and it will point to the one before that we want to remove. So that would be this one right here, okay? Actually, I guess I should draw one more in there. Sorry. Okay, so that's where node will get a reference to this node right here, right? And right now its next is pointing to this one right here. So what we'll need to do is go 2 down, wherever node is, right? We're going to set this arrow and make it instead go to this one right here. So that's the change that we need to make. So we just kind of bypass that node that we want to remove. So we'll set the value of nodes next to 1 past. The element to be removed. All right, and then that will break this one right here. That one will no longer be there. And so C then will be garbage collected, right? Nothing will be pointing, there's no reference to it, so this node will go away. Okay, so that's the idea. Okay, so let's see how can we accomplish that in code. All right, so here, old elements, right? That's, and then I forgot to, we would decrease the size and return the old element. We would still have to do both of those things, but we've already kind of done that here. So the old element is here, then we'll have an else clause here. All right, we need to get the node that's before the one that we want to remove. So we would declare a variable node here and use the get node method and go to index -1. So again, this is why we couldn't do it with index 0, because we have an index -1, right? And so this will get the node that's before it, right? So that's 3, or 2, I guess, here. All right, and then 3, we need to make these changes over here. So what we need to do is to set nodes next. So this is pointing to the one that's before it, right? So we would do node.next equals, all right? And then what we need to do is to go 2 down. So we're at node right here. This is the one that we have a reference to. So if we do node.next, that would be this one. And then if we do .next again, that would be this one. So in code, that's going to be node.next. So go to wherever node currently is, go to the next one, and then the next one after that, and then make node point to that one, okay? And so that should accomplish what we need to accomplish there. Okay, so let's add some test code here and just run through that really quickly. We'll do system.out.println words.remove, and let's do, I don't know, 6 I think is in range here. Okay, so let's step through this one. All right, so stepping through, I get the old elements. So we're at index 6, that's 0, 1, 2, 3, 4, 5, 6. That's the F. So we should see that here. Old element is F. If index is 0, which it is not, get the node that's before the one that we want to remove, right? So index -1. So when we get node, it should be pointing to E here. So there it is. It's pointing to the one right before it. All right, and now we just need to take this arrow and make it point down over here to G, right? So that's node.next. So that's the one I want to point to, and so here we're changing the value of the next field to point to that node. All right, so now E is pointing to G. You can see that F got garbage collected, right? And we have removed that one out of there. Okay, that is it on this one.